Now that we introduced the idea of gamma distribution, let's go over an example. In the following example, we have the case. In a study involving rats, a dose response analysis is done to examine how varying levels of a toxicant can influence the rat's survival time. This toxicant is commonly released into the air as a byproduct of jet fuel. Now, for a specific dosage of this toxicant, the study finds that the survival time measured in weeks basically follows a gamma distribution. Follows a gamma distribution with alpha to be 5 and beta to be 10. We want to know what is the probability that a rat, which is randomly selected, that a randomly selected rat will survive for no more than 60 weeks. No more than 60 weeks. So basically, we want to use the gamma distribution. We are calculating the probability that x is less than or equals to 60, which can be calculated as the integral 0 to 60 of x to power 5 minus 1 e to power negative x divided by beta, which is 10 over gamma of 5 times beta, which is 10 to power 5 dx. But as you can see here, you have a complicated integral. We prefer to use technology to calculate this integral because you get x to power 4 and e to power negative x divided by 10 and gamma of 5, which is 4 factorial, 10 to power 5 dx. What are we going to do instead? We're going to use a lighter version of this integral and then use Python to do the computation. So basically, what we're going to use, we're going to use an incomplete gamma function. So let me write this guy down here for you before we compute this integral. We will use the incomplete gamma function. Then we're going to jump into Python and use Python. The probability that x is less than equals to x is equal to f of x with parameter alpha and beta, which is f of x divided by beta with, in order to use incomplete gamma function, we can make some adjustments. So basically, we can write y, let me use a different color here for you. We can write y to be equal to x divided by beta, or x is equal to beta times y, and you can write down your cumulative density function f of x and alpha to be the integral 0 to x of y to power alpha minus 1 e to power negative y divided by gamma of alpha times d of y. Now you can calculate the probability that x is less than equals to 60, which is the integral 0 to 6 of y to power 4 e to power negative y divided by gamma of 5, which is 4 factorial or 24. So the probability that x is less than equals to 60 is the integral 0 to 6 y to power 4 e to power negative y divided by 4 factorial dy. Or you can write it this way. F of x, which in this case is equal to 6, and then your alpha, which is 5, is equal to 0 to 6 y to power 4 e to power negative y divided by 24 dy. Now you can basically use your Python and run a few lines of code to do the computation. We can use Python to calculate the cumulative function. What you can use, you can basically use scipy.stats since we are using gamma function, gamma.cdf. So make sure to import, let me use a different color. Import scipy.stats as like stats, and then set alpha to be 5, your beta is 10, and x to be 60. Define a new variable, cdf underscore value to be stats dot gamma dot cdf, pass in x, your alpha, and then set the scale to be beta. We talked about this at the beginning of lecture about gamma distribution. You can also print this variable, cdf underscore value, and you should get a probability to be around 72%. So after you run this line of code, the probability that x is less than equals to 60 is f of 6 and 5, which is about 72%. So again, remember that, just a quick reminder for you. In this proposition, we have the following. Let x have or follow a gamma distribution. with parameters alpha and beta. Then for any positive x, the probability that x is less than equals to x is the cumulative function of x with parameter alpha and beta that can be written as the cumulative function of x divided by beta with parameter alpha. This is incomplete gamma function. So this is called incomplete gamma function. So again, here I use Python because it was easier for me to grab this scipy.stats and use the gamma function built into this and do the computation.